lights out manufacturing. What does that mean? It means physically the plant is completely automated. Raw material is loaded on one side of the dock, comes from our trucks and whatnot, and the finished product comes out on the other end. You don't even need any lights, meaning you don't have anyone in the plant, physical human beings there doing the manufacturing. It's completely automated.
Welcome to another episode of Contra Minds. In this episode, I am talking to Sridhar Ramasamy. Sridhar is an engineer who moved to the US and is a veteran in building digital factories and is an expert in Industry 4.0. Sridhar took a career path not taken by many. He did not go and join an IT or a software company, but he went into manufacturing. The fact that he went into manufacturing helped him look at manufacturing processes which were completely manual, and a whole set of digital transformation was happening to manufacturing industries. And he learned those skills, and that's what he shares with us in this episode. The fact that you need to have interdisciplinary thinking, learning from other industries, have curiosity, have the discipline and the rigor to learn every time, ask stupid questions, ensure that you don't have the solutions, observe people, observe processes are some of the things that he shares in this episode. Let's get into the conversation. Hi Shri, lovely talking to you, and really great to have a conversation with you on digital factories.
Yeah, me too. It's been almost 30 years since we met after college, so it's been a long time. And thanks for the invite, and hopefully you find some material that's useful and make it into the podcast.
Absolutely, Shri. I think having done electrical engineering, today you are actually into building digital factories, right? So.
Yeah.
Can you tell me, you didn't take the normal path of going into software engineering and getting into IT, and so where did this interest in manufacturing, come about?
Yeah, after undergrad, I worked a year and a half in India working for a TVS washing machine plant, and so they trained me on lean manufacturing, just-in-time production. And so I got my interest in more on the manufacturing side. I actually wanted to be in operations. So when I came to the US, I wanted to actually do MBA, but I ended up deciding, okay, I'll do actually electrical engineering. I continue with my electrical engineering, get my graduate degree. So when I graduated, it was in Wisconsin. Because of the visa and everything else, and I was able to do 1 year of more like a trainee program with the steel company, and it was a much smaller company, and again, I get to do a lot of different things, not just engineering. And the first opportunity was this heavy manufacturing, and that's how I got into manufacturing rather than going into programming. And obviously, it was an automation engineering job. You get to do a little bit of a programming as well. It was not like you stayed away from it, but it's also traditional engineering, designing control systems and things like that. So it's a mix of both. So yeah, that's where it came apart.
So one thing that I see is, you got a career which is very interesting, which is, you got into smart manufacturing, you got into digital transformation, you've been doing digital transformation in aerospace, pharma. So one thing that I can see is that, you've been a curious learner all through your career. So how do you really prepare yourself for such a diverse career, given the fact that, you started off in electrical engineering, but now you're really talking of a whole different industry. So how did you go about preparing preparing yourself for such careers?
Yeah, obviously this is based on my experience. Necessity made me to learn different things. So when I was in the steel industry, it was a much lower profit margin industry. So the engineering and the automation, that's the easy part. You can get it done. But eventually, it came to a point we wanted to be more efficient. We wanted to make it right the first time, things like that. So then you're going beyond that. You started looking at how do I use, or make product the right way. In steel industry, most of your cost is in conversion, the energy you put in. And once you put in, there's no recovery. And if you don't make the particular grade, you lose your money, right? So from just being an engineer, now I'm talking about more of operation. How can we make more profit? How do we make quality products? So that's where the data analytics part comes in. And when I started, a lot of steel industry, we have very limited automation. We didn't do a lot of data analysis and things like that. So we started building even those days, we didn't call it machine learning or artificial intelligence. We had a finite, a constraint problem. So we simplified it and we tried to solve the issues in the controllers. That's what we had. So kind of going from being just an engineer, now you're thinking more of how do I optimize my process? So necessity made me to do that. And then after 15 years working there, I get a chance to build a brand new plant. So I get to do a lot of my, use my experience to design it in a way I wanted to design it. And I definitely had a lot of external vendors to partner with. So we built a really, state-of-the-art facility in the Cleveland area. And then I'm getting bored in the steel, and at the same time, when I was, we started up the plant, and our utilization was like about 45% on a brand new plant, and should be anywhere from 80 to 90%, and we're not getting it. And there's a lot of issues, startup issues, premature failures. All of a sudden, being an engineer from operations, now I'm looking at reliability issues. So it's the different circumstances and different things I was going through during my career made me to learn new things. So I started working on reliability engineering, manufacturing support. How do we improve my plant, life? And so that kind of dictated my next job. So Swagelok, a local company, makes a lot of CNC machine fittings, and they had some automotive parts also. They hired me as a reliability engineering manager and manufacturing support manager, and I started managing. At the beginning, it was just 2 plants, and then they ended up being 6 plants, so I completely off. It's more of a managing people, and then I also learning how to improve equipment reliability. I never worked on a CNC machine in my whole life up to that point, and all of a sudden I'm learning about CNC machines. So definitely, you have to take advantage of what is in front of you, what is available. Be curious, continuously learning. And also, if you think it is just a job, then it is a job. And then, you had to think about it as a career. My career is, the way I like to define it is how can I help companies? How can I help individuals? Definitely, I mentioned during the beginning, I'm not a great programmer, so I had a lot of support. Engineers, throughout my career, they supported me, my teams. To make me look good. So in turn, their success became my success. So facilitating, helping them be successful. So that's what I try to do.
So when you hear Sridhar speak, he talks about the importance of an engineer knowing the business problem. Why are plants making such low profits? What do we do to improve utilization? And then they find a solution. So if you are an engineer, the need to be curious about a business problem, and the importance of working with people seems to be a very, very important critical aspect of how you can be successful in your engineering job. Every time you tell me, I get an interesting perspective, Sri. So one thing is, you actually talked to me about the fact that you went and discovered things that you never done before. Okay.
Yeah.
That's not how probably the engineers of the past were, right? In the last few decades. So therefore, when you wanted to get there and start looking at reliability engineering or smart manufacturing or using automation of plants and things like that, what was your method of learning? Okay. Was it because it's a very important thing. One is to actually get completely stuck saying that I won't take any risks and make mistakes. So how did you go about learning, reducing your mistakes, and building a career around probably the most in thing today, which is digital factories? So what were your key tenets that you can share with us?
Yeah. Learning. I'm not a patient book reader. Anything. If I buy a new toy, a lawnmower, for example, uh, I wouldn't even read a book, and I'll try to figure it out myself. It's like assembling an IKEA furniture. A few times I was screwed up or put the wrong bolt and wrong screw, and so I'm more of a tinkerer and trying to be hands-on. And early on, the one thing I learned to do is go watch the process, go listen to the people, and they want to tell you, and they help you learn things, and you learn quite a bit by watching and observing. And I give you an example. I didn't know much about reliability engineering, and I got hired. Peter Sheard, my boss at the time at Swayzak, I don't know what he saw in me, but he did hire me and gave me an opportunity and hired me. I hired this maintenance planner, and he came from an automotive company. He taught me everything about doing maintenance planning in any company. I used to get mad at him and say, why are we not putting all the equipment in preventive maintenance? And he walked me through the process and said, look, without plans and without parts, a preventive maintenance plan is not a very good. It's just a paper plan. It doesn't work, and you don't get the efficiencies and yields. So you taught me all the nuances. So that's kind of what my MO when it comes to learning. You go talk to the people, learn from people, and obviously you do have to do some book learning and some even coding and things like that. You have to do a little bit on your own. So that's kind of how I will go about learning. Listening to the people and asking some questions. Sometimes they're not the very smartest of the questions, but that's how I learn. Yeah.
Sridhar here talks about the importance of observing and watching. Think back and look at what you do every day, and then reflect on how deeply do you watch and observe people, processes, and business problems. I think that provides a host of ideas for you to solve business problems. And as an engineer, it's very critical to ask stupid questions, and you don't need to worry about why it's not so intelligent. I think the fact that you need to ask those stupid questions and keep asking them again and again to understand the core business problem and therefore get deep into why this problem is occurring, and therefore you will find a solution at the end of the deep pit. That, I think, is the most important, and you don't need to get embarrassed asking idiotic questions. That, I think, is a very key message that he gives out in this discussion. In schooling, in college, we are all taught about saying the right thing, right? But suddenly you go to an industry which
Yeah.
is, you got to set up a plant. You basically have to go and do an industry, category where probably you are not, not knowing. So how did you deal with ambiguity? So how did you break it down?
Yeah. Oh, that's a great question. Ambiguity and the culture, right? Where we come from, you don't question the professors or and I think the professors. I don't know. Maybe my dad was a professor, so I shouldn't generalize it. Uh, you don't. Yeah, that's a great question. So I think in the U.S., so that's one of the things they teach you in schools, and they challenge you on everything. You can't just assume that your view is the right view. You better have good answers and good explanations before you propose anything, right? So you have to do your homework definitely, and a lot of times, being I think when I started out as an automation engineer, a lot of times I had to help with the maintenance or troubleshooting and things. And you walk in, equipment is down, plant is down, and I think hour every hour the steel plant was down, we were losing like $100 or something like that. This is almost 30 years ago, so it's a lot of money. And so there's the company was a private company, and there was a lot of pressure, and everybody got benefit if we made good tons. So there's always a pressure when you walk in, and so early on, you got to have good discipline. And so, lean teaches you. That's one thing I learned. So that's why I go back to my lean training, to listen to your people, and that's one thing. That's important for me. So you walk in any situation could be, you don't know what you're going to deal with, whether it's a maintenance troubleshooting or a problem you're trying to solve. And later on, when I was working for Alcoa, we're an aerospace company, we're supplying parts, and I was in the digital transformation team. We'll go to different plants and different sites, and we walk in, they had different problems. One had efficiency issues, they're not making fast enough. Others had quality issues. So different issues you had to walk in. So you go interview, you spend time in the field, so to speak, and learn before you open your big mouth to start suggesting things. That's important, when you're dealing with ambiguity. Also, you try to apply instances and cases from parallel industries and parallel observation. That helps when you're dealing with the ambiguity. And there's no substitute doing homework and reading up on things. Those are the things. And so to me, it's a multiple different things. There's no like a black and white when it comes to ambiguity. And also, eventually, your experience also comes into play. They call it gut feeling. Gut feeling is based on experience in my mind. So those are the things I generally use.
So if you look at this section, Sridhar talks about how he deals with ambiguity. Most often in our education systems and in whatever we do over the first 20 years of our life, we actually know what questions are going to be asked, and we are prepared for answering those questions. When you get into a business and when you get into a job, most often the problem is not known. Therefore, the importance of observing, understanding the business, looking at the business problem. And if you look at some of the points that he says, he does not talk about the solution first. He talks about listening to people, observing the process, understanding the business problem, and that I think is very, very important. He talks about the importance of discipline and not jumping to conclusions by first looking at each problem in a most modular manner, and then you go back and then say, okay, this is how probably you may need to solve. So the importance and the criticality of looking at the business problem, observing people, observing the process, and learning from it is very, very important. You talk a lot about lean, and maybe you are leaning on lean, right, in solving problems. So what are the key tenets of lean that you carry with you even today?
Even dealing with my kids and my family, I kind of try to the one thing I learned early on is I'm always not right. I think I know the answers, but a lot of times 50-50 chance I may be wrong. So you walk in that's one thing I learned to do, observe. And then the third thing for me is uh, data. If you have good data, there is no substitute for having a data and letting the data dictate the terms. So uh, often you don't have good data available. In one instance, I just took a job. They gave me two plants at Sridhar, and we didn't have good data to go by or how the plant was performing. All I had was an Excel spreadsheet I had where I was logging the spend, the POs, purchase orders we were writing. And I started using that for the first month or so and started looking at. So that's, it gave me a pattern, things I know we were calling a lot of external help and to troubleshoot and fix our machines. And then when the help came, I started focusing on what they were doing, and they were working on equipment unsupervised. So some behaviors we needed to change. So I started assigning technicians to work with them, and that helped them to keep an eye on what they're doing. And also they were learning on the job, so to speak. So you have to start with the data. So those are very basic fundamental things. Have an open mind and understand that you're not always right. That's one thing. Observe and listen, talk to people. Third thing, use any data that's available for you to, dictate what you will do.
Fantastic. So in this section, if you look at what Sridhar is talking, he talks about the importance of an open mind and data. Most often, this aspect of an open mind is not given so much of an importance, especially when you're working with people, when a business problem is thrown at you, and if you have all the experience, you pretty much look at how to solve the problem. But when you have an open mind, your ability to look at different perspectives, question your own biases, and therefore understand the business problem better is very, very important when it comes to looking at how you will suggest a solution. The other thing he talks about is looking at every piece of data. Often this is a misnomer that I see, where people come in and then say, where is the data, or I have too much of data. In fact, what he really talks about is picking up small pieces of data and trying to understand what these small data elements mean. It could be in the plant where a simple sheet is being maintained, where data is picked up, patterns are being looked at, and when you look at these patterns, you realize that there is a business problem that can be solved, and therefore having an open mind and looking at any data element that you have access to can throw up interesting ideas and solutions. So you are at a stage in your career, Sri, where from a great manufacturing nation, US moved all manufacturing out of the country, right?
Yeah.
So in a way, you are, you did something contra, right? Which is because you are actually, all manufacturing pretty much moved out of the US. Mm-hmm. You still, pursued with the manufacturing, domain that you started in. Was there any specific reason you saw opportunity What did you see which others did not see?
That's a great question again. Uh, so I was always fascinated by manufacturing early on. All my cousins and they're all in manufacturing, and so that influenced me definitely. So most of my career, I was lucky enough to work for private companies. And my first job was with a steel manufacturing company, Charter Steel, in the headquartered in Wisconsin. They're a privately owned, family-owned company. And the Mellows family, they had a philosophy: no layoff policy.
Okay.
And even when the business was down, they guaranteed 35 to 40 hours of paid work for their employees. When other companies and steel mills were laying off the people, the employees will come in. They may paint or clean up, do something. They may not produce steel, but they got paid. And what it allowed them to do was be ready when the upturn came.
Okay.
And they actually invested. They bought new equipment, and we did a lot of project work during downturns. It's a fascinating philosophy. And when I started, that company was like 150, $200 million company, and I think they were now $1 or $2 billion company. I don't keep track of them, anymore. So it organically they grew, and it still is maintained as a family-owned business. So to me, there is always a way to be successful if you have. If you have a clear path and a clear thought, in a lot of ways, I think Indian businesses, I've seen it over the years. They don't do a lot of mass layoffs and things like that. They still run it as a family, started companies. I go back to my TVS days. I see notes about the Kirloskar and the Tatas and some of the Indian companies. They do the same thing, and I think culture has to do with it. And some of the Indian U.S. companies are also the same way. And another company, Swagelok, again, is a family-owned company, and they acted the same way. And they thrive, and they still thrive, even when other industries, their peer groups were suffering. They always thrived. So, I was fortunate enough to be in those companies, and I always moved up in those companies. So I didn't really see need to jump and say, "Oh, I'm going to be an IT person." And then after 15 years, sometimes it's kind of a little typecast, right? It's like acting, the actors are typecast into a role. That did happen. But, going back to your question, how do you change your career? So that's why, curiosity. I also got bored and doing the same job after a few years, and I always wanted to do something different, better. The one thing I always kind of try to do is, how do I do my boss's job?
Hmm.
This is something I learned somewhere, and if I can do my boss's job, my idea is that they will see me value, and they will promote me to those roles. And that did happen. So yeah, that's why I stayed with the manufacturing. I still love it.
So in this section, Sridhar talks about doing your boss's job. That's pretty different from what I've heard. Most often, what I've heard is, hey, this is my role, this is my description of what I have to do, and this is what I'm supposed to do. So when you take up something, when you really start saying, how do I do my boss's job, there are a couple of things that you're putting in the dock. One is your knowledge of how you can solve a problem far ahead of your capability. The second one is preparing for it. And the third one is ensuring that you become successful in that. And he also talks about another important philosophy of his value systems and his beliefs aligning with some of the family-owned business in the US, where there are no mass layoffs. There are times when they're being paid when there is a downturn. They go and clean up factories, get prepared for an upturn in the business cycle. So there was this philosophy that he believed in, having come from a culture like India, and therefore his alignment of the value systems and beliefs, and therefore the kind of job that he started picking up and then doing the boss's job. I think if you want to build successful careers, you need to look at all these anomalies and all these interconnections, and that allows you to build a career with a purpose. Do you believe US has moved away from its competitive space of manufacturing that it had, and has that been one of the reason for I would say relatively slower adoption of digital and transformation in manufacturing?
It depends on the industry. So automotive been doing this almost 20, 25 years ago. They're highly automated, not just physical automation, digital automation also. They're collecting a lot of data, and some of the quality improvements. When you talk about Six Sigma, automotive industry truly follows, and as a tier two suppliers, we had to learn to, when we supply to automotive, we had to learn to do those things. And so they've been doing it for a long time. Other industries like aerospace, it's a high value, but not a high volume products they were making. So you make, for example, maybe 10 F-35 bulkheads. These are big structural components where engine gets mounted. Each one was about, I think, of $500,000, something like that. They will make about 10 per month, and that's how many they were assembling. And so this is, and it is a very involved product. It will take a couple of weeks to make one of these things, right? So those industries, they didn't have a real incentive to really, take go digital all the time. And also, pharma is another example. The profit margins are really high, even from 20 to 40, 50, 60% profit margins. And a lot of times it's the mindset. They don't want to kind of break something that's working, even though it is paper-based. So that's that's one of the things I tell when I do digital workshops. It's not the tools, it's not the skill set that you need to do digital. It's the cultural mindset. Do you have enough lean ideas, mindset within the plants, within your thinking to go digital? That is very important. That's one of the biggest barriers I see to go to a digital factory mindset. And on the contrast, when you look at newer companies like Moderna, for example, or BioNTech, and some of the vaccine companies, they didn't have any product, so to speak, until 3-4 years ago. Their first product is COVID vaccine, but they were ready for it. And they look at, they have some papers that's on the AWS. It's readily available. They show you what they do. It's not like a secret or anything like that. They're end to end, they are connected enterprise. A batch release in a pharma industry typically takes anywhere from on average 2 to 4 weeks. Moderna can review their batches within a couple of hours. Right, because it's digitized, and they're not looking at everything they don't have to their system, so they help them. They don't. In each and every stage of their manufacturing, they have checks and balances electronically being looked at, and they proceed, from step to step without making a lot of mistakes. And so that's a pretty typical in automotive. Whereas pharma is now waking up to that reality, and they're started setting up that. So it depends on the industry. And on the other extreme, you look at someone like Apple making iPhones. Foxconn is highly connected, highly automated industry, and they are coming to manufacture in India. They're setting up plants in right. So you're going to see that's happening quite a bit. Yeah.
Okay. So here, if you observe what Sridhar talks about, is this importance of not whether manufacturing is done in a country like US or it's moved to some other country, but the importance of the mindset of how you build a completely connected factory. So he talks about the criticality of having a mindset for digital, and he really says that I may be a traditional industry like aerospace where it's high value, low volume business, or it could be a pharma business where traditionally, it takes, a couple of weeks to really look at batches, while, there are companies, new age companies, which can do it in a couple of hours, right? So therefore, when it comes to digital, it's a cultural mindset of looking at how have you been operating over the last, many decades or many years, and you are looking at how you should move into a digital first mindset. And there you need to break your traditional thinking, look at interconnected patterns, look at interconnected processes, and that's really how you start building a digital factory. And that is important when you do digital transformation. So that gives me a good segue to ask you a question on what is a digital factory?
So digital factory, there are, I mentioned earlier, depending on who you ask and which industry you ask, you're going to hear a lot of different answers and a lot of different ideas about digital factory. So, digital transformation exists in every sector, every industry. Whether it's retail or manufacturing, it means different things to different industries. So in manufacturing, that's my, I have years of experience, almost 30 years of experience there. On one extreme, lights out manufacturing. What does that mean? It means physically the plant is completely automated. Raw material is loaded on one side of the dock, comes from our trucks and whatnot, and the finished product comes out on the other end. You don't even need any lights, meaning you don't have anyone in the plant, physical human beings there doing the manufacturing. It's completely automated, robots and material handling equipment and equipment running. And so there are factories like that. The famous example I heard about, I've never seen it, is a Fanuc robot making plant somewhere in Japan. One of the sales engineers, they always invited, hey, if you want to go see, if you're in Japan, you can go see. That's the extreme end of it. Oftentimes what you see is, some form of physical automation, and of late, a lot of digital automation. Manufacturing generates ton of information. The data is collected and stored locally, or sometimes fed into corporate servers. Most of the data, almost 80-90% of the data that it goes unused. The data never gets translated into actionable information. But
So
to me,
what kind of data gets stored in corporate servers in manufacturing?
Every millisecond, there's something collected. If an operator pushes a button, if a temperature changes, if a robot moves, everything is observed and collected as data and gets stored. And so it could be equipment status data, how equipment is working, or a product related data, like at what temperature a product was made, or at what speed was it made, things like that. So anything you can see, observe, it is getting collected and stored. And most of the time it gets stored and it's sitting there not being used. and often when
So
there's
my question is, how is it collected?
so on a modern digital factory, you have sensors of the all these how it is collected and everything is defined by a standard called ISA 95. It was developed way 30, 40 years ago at the Purdue University. It used to be called Purdue model, and it describes how different systems at different levels of systems classified and how they talk to each other, and from all the way from the shop floor, the sensors like a temperature sensor or a speed sensor or anything, all the way to the corporate systems like the enterprise resource planning, ERP systems, product lifecycle management systems, customer CRM tools. The ISA 95 model describes that. And so at the shop floor level, at level 0, level 1, you have sensors, you have programmable logic controllers talking to the sensors, and the programmable logic controllers in turn are talking to SCADA systems or MES tools. SCADA is a supervisory control and the data acquisition systems. These are all more of a software systems. So the lowest level, the data is collected at milliseconds and microseconds. As you go up, the data gets consolidated at the PLC, still milliseconds. At the MES or SCADA systems, maybe seconds, minutes. As you go into ERP, it's more of days and weeks, and that's how its data gets collected, gets filtered. For a ERP system, they don't really need to know how fast a product ran. Rather, they want to know when the product will be done, production will be ready to be shipped out, so they can give that information to their customers. So that's how the systems work. Yeah.
Okay. So if you carefully observe what Sridhar talks about, he says that in most companies, and especially in manufacturing, which is the example that he talks about, there's a lot of data that often gets collected but often not used. I think this is something that all of us need to think, saying, hey, is data available? Of course, data is available. Is it being used? Most often it's not being used. That's one part of the problem that I think, you need to think. The other important point that, I see here in this point that he makes is that if you look at, industrial transformation, you did physical goods. The physical goods were not automated. Then you started looking at, hey, how do I do a lights out manufacturing process where there is no hands touching right from the time when, the products, the raw materials come from the stockyard to actually becoming a finished good. So that's really how physical factories really started changing, and then you started saying, how do you really do a lights out manufacturing process? Now, that is probably exactly what's happening to knowledge factories, where you had physical people, you are doing the programming, you are now doing the programming, you get a lot of business problem, and then you start looking at saying, hey, how do I really automate the process? So, there is a requirement that's coming, there's a solution that needs to be built, there is a software that needs to be done. So now you have the AI and the machine learning really looking at saying, okay, how do I solve this problem? So the fundamentals of how from an industrial economy to a knowledge economy, the change happened over the last 50 years. The tenets of how do you build a digital factory for a knowledge industry pretty much can be learned from the manufacturing industry, and how the transition from industrial economy to a knowledge economy happened, and therefore how digital factories were built in the manufacturing sector. And that's really how I think the knowledge factories of today will become digital factories of tomorrow. So therefore there are these bunch of components sitting in the shop floor, and they are throwing the data from the sensors to the PLCs to the SCADA systems, and then they get into some kind of a server, and they remain as raw data, and that's really how this whole data gets collected. So when you look at a digital factory,
Yeah.
I think very interesting data point that I read was most companies are moving into becoming digital factories, right?
Yeah.
Because
Yeah.
they, like what you talked about Moderna, right? Basically, it takes a couple of hours to produce a vaccine. So real digital transformation has to happen if manufacturing needs to get and needs to get digitally connected. And
Mhm.
so therefore, my question is, in the digital factory, how do you define, if you want to become a digital factory, what are the steps that you need to take to say, okay, how do I define maturity of a digital factory, and
Yeah.
how do I then move from one level to the other, and how do you really think through this? Because there are components that are, if I go to Amazon cloud, they say I also have a manufacturing cloud, and then you can
Yeah.
get in there, kind of a thing. So what are the key components for this digital factory becoming really valuable to an enterprise?
Yeah. That gets into the heart of the digital factory. That question right there. This is where the uh, when you go into any factory these days, they are somewhat connected. They are collecting data. You're hardly going to see any modern factory. The sensors are you're not going. They're already there. It's not like they don't have anything. There is some resemblance of a digital factories there.
Mm-hmm.
And typically, to do a digital factory, the process I'm familiar with, and most people will follow, is there are some tools available, digital tools, industries, digital plan maturity, matrix, and some tools are available. They are Excel spreadsheet based, and there's even some software tools are available. And they give you a template of questions to ask.
Mm-hmm.
The pharma industry, for example, uses a tool from that's recommended by ISP, is International Society of Pharma Engineering, and a few of these trade groups. They have defined these tools and say this is how a pharma industry should look like. And so these tools are available, so you could use them. But at the end of the day, each tool has to be personalized a little bit to the industry, to the company, and that's where an assessment comes into play. Employing someone like me or someone with my background and experience, there are several consulting companies. They do this kind of work. McKinsey does it. Pricewaterhouse does it. And pretty much every consulting company, they have a practice now to come in and help you with the assessment of where you are in the maturity index, and they will compare you to your peer groups, and you can also even compare to other industries. From automotive, you can compare to pharma and things like that, vice versa, and you can benchmark yourself. And so you can do that, and that takes 3 to 6 months of assessment at the beginning. That kind of helps you to level set where you are in your digital maturity.
Mm-hmm.
So there is a scale 1 to 5. So you can put yourself in, typically I tell for most companies, you're either around 2. That's my experience when you go through this assessment. But that index or that score comes based on these tools that you can use to do assessment. So that's the first step. That's very important. And then based on this assessment, you do want to have heart-to-heart discussion with your leadership team and say, look, where do you want to go? What are you trying to do? What is the business case? What do you want to do digital? Is it because you want to be number one in your industry, or are you losing money? Or that's the real. You got to spend some time coming up with a vision for the company, what the digital vision is going to look like. And someone may come in and say, "Well, I want lights out manufacturing for every plant," but that's not realistic. And you got to have a pragmatic view of, okay, yeah, that lights out vision is what we want, and that may be 5 years, 10 years from now. That's what we're going to be. So some sort of a vision like that, you can define it, and then what can I do in the next in the short term, next to 2 years, 3 years, 5 years? What are the things I need to do? That's a roadmap you want to build next. And a lot of companies they go company wide. Every site they're going to do some level one type work on that roadmap. Some companies they go take a pilot plan. They call it lighthouse projects. And they take one plant that maybe are close to where they are in their digital maturity, and they say we are going to do these 4 or 5 different things. We're going to set up we're going to collect some data, or maybe we're already collecting data. We're going to build some dashboards so that converts the raw data into actionable information that the sites can use. So those are some of the projects you come up with. And typically companies do proof of concept pilot at one site, and then, make sure everything works the way you like it. And then maybe you try to lean it out, use some agile methodologies, and build some playbooks. And then you can give it to every site and tell them to go implement it. So there's a lot of different ways to build that roadmap. So that's a typical process. So when you're doing that, we also have to have good assessment and also good report back to your leadership. And the key in this whole process is the buy-in from the highest level of the company, CEO on down. So
here Sridhar talks about mixing pragmatism with innovative thinking and balancing it with business realities. That's really how I think most often innovative ideas such as building a digital factory, getting into transformative work like digital takes shape. What I believe he's saying and is very important is there are tools and tools and tools, but there is a need to customize it to your environment, your business challenges, and your objective of where do you want to be. A tool cannot take you to where you want to go. It's important to know where you want to go, and a tool is a catalyst. So when you're looking at something like a digital factory, the important point that he makes here is the fact that your vision, your leadership buying into the philosophy of lights out manufacturing, looking at profitability. So the business issue comes to the fore. So if you're an engineer having access to the best of the technologies, the fact that you need to put it back into how a business looks at the problem and therefore connect it back to any of the technologies that you have, and therefore which of these tech platforms, which of these tech solutions, in this case it could be a SCADA system, it could be something that is a PLC that's connected to machines. There's a lot of disparate data that's available. What's important is to have a clarity on where do you want to go, and then apply a digital transformation process and a roadmap, and that I think will make it extremely successful. So when you say there are tools, what I'm learning from this conversation is there are tools, but you have to get your strategy right?
Absolutely.
So I think that's really a very important point that you're talking about. So can you give me an example of how do you get a strategy that was right, and therefore it became a digital factory, and therefore what kind of outcomes and returns have some companies seen, and therefore can you give me a real life example of how to define that? Because when I look at a manufacturing plant, at least what I have seen is that, my productivity should increase. Okay, my efficiency should get better. My asset life cycle should be better. Okay,
Mhm. Yeah.
I've heard these kinds of things. Okay, but
Right.
when I'm actually looking at a digital factory, are there some larger business goals which are very different from the traditional analog factory to a digital factory? How do you assess what kind of business goals can I set for myself?
Well, I wouldn't say they are too different. At the end of the day, any business, or their end goal is to make money, right? You see a scene, slogans, we want to save people's lives, we want to do good, do no evil. All those things are slogans at the end of the day. But bottom line is you are there to make return on investment for your investors. So how you go about doing is what differentiates the companies. Digital factories. There's a hard way to do and there's an easy way to do. And the analog factories, they do it in the hard way. You can inspect every bolt and nut that you manufacture. And even in China, the low labor costs, it's becoming prohibitively costly to do that kind of a work. And that's where the Six Sigma, the million parts per, PPD, reducing the defect comes into play. They want to make sure you produce it without inspection. You can either inspect quality or you can produce quality. And so that's a mindset you need. This goes back to the lean mindset. That's where it comes from. All these things comes from. So to me, that's thinking in a digital factory. But Madonna, for example, decided they're going to be completely cloud first manufacturing, and they hardly have any servers or anything in their factory. So that's they can do that because it's all greenfield. They were building a factory, so that's how they built the factory.
So how do I become a cloud first factory?
On a greenfield site, it's much easier because you're starting from a empty canvas, white sheet, so you can design it the way you want to do, and you connect everything. You make sure you have good internet connection and everything. Your network is up to speed. So you design everything to that effect. Okay. I'm running everything in AWS. That's what Madonna does. But 90% of the companies, they're not greenfield plants. They're what we call the brownfield sites. They have existing assets. They're high-performing assets right now. You're not going to abandon it. There's no business case to rip and replace. You still have to bring them to the digital factory side of it. And that's the biggest challenge. That's why some of some of the challenges really is to go about and say, okay, I'm going to be a digital factory. So how do you go about doing it? So that's where in the roadmap I was talking about comes into play. If it is a greenfield, you start from scratch. That's the easiest way to do it. Brownfield, you obviously want to do it gradually. And so each site may be, in the same company may be different. They may be assembling cars. One site may be 40-year-old site, another site may be 15-year-old site. So they may be in a different maturity level. So that's why you do have to individualize and you have to adjust your strategy. That's where the strategy becomes more of a, when I say strategy, you think it will be set in stone. It never is. It is a dynamic strategy, and it is going to change site to site. And so you definitely need a corporate strategy to say, this is how I'm going to implement it. This is how I'm going to pay for it. And, at the corporate level, you may say, I do see a value doing everything on this side because that's already performing at 90% level, and I'm trying to get the remaining 10%. And that probably is the hardest because you have, got all the low-hanging fruits with the 90% performance, and the remaining 10% performance is the hardest one to get. So you may want more data, and that site may provide you more data because it's already high-performing sites. So that's one way of approaching it. The other way of approaching it is a low performing site may have a lot of low hanging fruits that may be easy to solve also. So
Mhm.
that's where the strategy comes in, and you have to make up your mind based on case by case and say, this is what my approach is going to be. If I did $1 million on a low performing site, I may bring up the performance 20-30%. Or may have to spend $10 million to improve the performance of a site that's already performing 90% level. I may improve only 1 or 2%. So that's where use the data to help form your strategy.
Okay. You'll observe in this conversation, Sridhar spent the last couple of minutes talking about strategy. So here is an engineer trained in math science talking business strategy. So as an engineer, as you move up an organization, the value you provide to an organization is understanding the business strategy, the business realities, and ensuring that the technology and the platforms and your engineering skills come to the fore. This balance is very, very important. Life is not just going to be about just solving some engineering problems. As you move up, your ability to look at the big picture, look at what the industry needs. So that becomes more and more important. Therefore, what is critical, and therefore what is important for you is to look at saying, okay, what's the business problem I'm trying to solve? How many different kinds of business problems are there? Which of my engineering skills and engineering problem solving skills can I use to solve this business problem? What are the high maturity problems that require top engineering skills? What are the low maturity problems that require low level engineering skills? But what's not going to go away is your ability to mix your business strategy, understanding of the business problem with your engineering skills. That is going to remain forever. So if I were to move from, say, a low performing site to a high performing site, let's take the example of pharma or automotive or whatever. We can take an industry. Normally, what KPIs really drive this change? Because I want the audience to get a sense of how do I get that change? Because normally, if I'm in an automotive factory, I'll say how many more cars would I produce? Is that what is important, or how many different models of cars should I be producing? Then the customization and personalization becomes very, very different. Okay. Or if I'm in a pharma factory, I'll say, I can produce 20 lines of different pharma products in per hour. Okay. So therefore, I just want them to get a sense of how they define the strategy, and therefore the importance of the digital factory in scaling it, right? That's very important.
Yeah. So the business case, coming back to the business case, right? And the business case is going to be depending on what you're trying to improve. So even within the same company, one factory versus the next factory, the business case may be different. So all those things you listed, reducing the cost, improving the operations efficiencies, improving the uptime of the equipment, product mix, improving the quality, doing it right the first time, improving safety, another one of them. And off late, we also started adding net zero and sustainability. That's also getting added to. Those are some of the key performance targets that the companies are using it. And when you're doing an assessment with some of these digital tools, those are also part of the questions you will start asking to side by side to say, okay, for this side, it may be efficiency. So during my work at Alcoa, when we used to go to different sites, each one had a different issue. One site had a quality issue, another site had a throughput issue. And so each one has to do things differently and had to focus on different KPIs. And so that's becomes a part of the site level assessments. So, we talked about vision, corporate strategy, and then we built a corporate roadmap. Now each site had to build their site level roadmap, and while you're defining it, you also have to define what is important to the site. And in pharma, one site may be producing bulk materials, another site may be taking that bulk material, filling them into small vials. So two different processes. Even though it's the same company, they may have two different needs and requirements. So that's where site level assessments comes into play. And the KPIs at the end, the high level, you still are going to look at the reducing cost, quality, improving efficiencies, throughput, availability. So each one will drive different behaviors within the site.
If you look at KPIs, when you define them, is directly related to what the business needs are and what the business challenges are. So if you are somebody in technology or in engineering, the fact that when you design KPIs, they need to understand the business problem, the business challenge, and therefore how do you define the KPI becomes a very important skill that you need to build over time. The KPIs that he talks about, go back and listen, and you will realize that most of them first are business issues. The business issues then get converted into data, and the data then gets massaged and analyzed to deliver that KPIs. And he also talks about the importance of linking a corporate strategy with a vision at the higher end and to a site level vision, which is to say, you know what, hey, I want to really improve my throughput. I want to improve my efficiency. I want to really build, one product at a time, and that I need to do at scale. Now, each site, depending on the investments that have been made over the past many years, because he talks only about few green fields getting set up, lot of them being brown fields. So in many projects, you enter when they are brown fields, and when it's a brown field and when you want to innovate, you incrementally chip your way through, and that's really how you will be able to show a difference and value to the enterprise. So this is an interesting problem that that hit my mind. I have in an automotive industry or in a pharma industry, if I have, say, 10 manufacturing plants, or if take Alcoa, I may actually be making, products in 10 different plants, 10 different plants having 10 different problems.
Mm-hmm.
Okay. But when I am a consumer or when I'm a customer, I may be a B2B customer, I don't care from which plant it comes from, right?
Yeah.
So if you solve a problem of quality in one, factory, and you are talking about demand for demand or customization, which is really what the market need is. Now, how do I really balance all this? Because at the end of the day, I have to measure all this against some metric which says is Toyota a reliable car manufacturer? Because I may have hundreds of factories, hundreds of different problems. So how do I then assess and actually say that Digital Factory has added value to the customer integrity or trust score or whatever that I were to call it?
Yeah. The same company, Toyota's example is a perfect one, because Toyota has thousands of vendors supplying products to them, especially in just-in-time type of production environment. And that's where the Toyota manufacturing system, the production system, TPM came about, product manufacturing system, came about, right? So, one of the things are, some companies, the way they do it is each plant and each site is being operated as its own profit center. A lot of times, one factory is supplying to the next factory within the same company. So if my raw material is coming from plant A, I should, plant B, I'm plant B, I need to make sure, and I had to treat plant A, even though it's the same company, same family, I need to treat them as my supplier. And I had to expect from my supplier the same thing I would expect quality and efficiencies and productivity that I would expect from an external supplier. So one way to handle it is you treat each plant, each line as a profit center, and that's one way of addressing that question. Another way is at the end of the day, the corporation is responsible for the product quality overall. You are exactly right. When I'm going to go buy a Toyota car, I don't care who made the bolt and nut. It's Toyota's name on the plate, and so it is. They are responsible. So if I had to take a guess, Toyota ensures every part that they manufacture meets that requirement, the quality Six Sigma requirement they may have, and that's how they are going to ensure. They don't, when the product is shipped to Toyota's plant, they're not inspecting the plant at their receiving end. The expectation is it is already come in the quality, and if it has to be inspected, it is done at the supplier's end, right? That's one way of ensuring, my product in every stage it is in quality. Another way is with the modern digital factory, every step of the way, that's one of the expectations when you're setting up a system to ensure it is meeting the spec. So, for example, if a product has to be within a certain tolerance, let's say temperature, I'm going to use the Fahrenheit here, so that's what these days I'm familiar with. Say if a product is has to be made at a 80-degree plus or minus 10%, and during your manufacturing process, that's what one of the expectations was. In the past, if a specification says, make sure the product is at room temperature, to me, that's not a very good specification. Room temperature in the US may be different in winter versus summer. So if a process engineer, or a product designer says, make sure the cake is baked at room temperature, that's not a very good specification. I want a very precise specification. And so this is where digital factory, when you say, I'm going to set up a digital factory, it's not, installing a bunch of devices, connecting controllers and systems. Is everything that I do from product design all the way to inspection, making and inspection, do I have a design factory mindset principles applied to that process? So it's not about operation doing something, engineers doing in the shop floor something that's going to make you a digital factory. It is an entire supply chain doing the things. And so in the case of baking a cake, I precisely want 80-degree Fahrenheit plus or minus 10% over a certain time. It has to be baked. That is the specification I'm expecting. That I can turn that into a recipe that I can give it to a PLC, programmable logic controller. It can use the thermocouple RTD to monitor it and report back to say, yes, I maintained that temperature within that tolerance for the 2 hours you asked me to bake the cake. Don't have to inspect it. Since I met those requirements, that cake should come in at that quality that you want, and it won't be burnt.
So when you look at what he talks about in terms of specs, a digital factory or any automation process, the importance of being precise is something that's extremely critical to being a successful digital factory. In the past, if you didn't automate and if you didn't have the data, you would probably give a certain large policy decision saying that, hey, this is how I want. But today, any process that you look at, whether you're building software or whether you're building a product, the importance of devices being tagged on from the time you start designing a product to the time you deliver the product until the time you service a product. The fact that you can use multiple devices to collect this data to a specification that you actually have on blueprint, and then start measuring it, and then finally you are able to connect all of them up. And therefore, the fact that interconnected processes and looking at data from different processes feeding into the next is very, very important. And therefore, siloed thinking is something that's not going to be important need that businesses have. Siloed thinking is something that will not succeed. Siloed thinking will create, islands of excellence. But what digital factories do is to build a chain of excellence across processes, and that is something that's going to be adopted by even the knowledge industry. So is that where probably the concept of a digital twin comes in? Because I am actually doing it. I have to do it on on a system. See how the product comes out, so that finally when I put it out in the factory where I'm selling millions of products, the investment is far more larger, and therefore is that what is called as a digital twin?
That's great. Segue. Yeah. A lot of ways it is. Digital twin is used in a lot of different ways. One of the ways is to, when you're designing a product, you want to know how that's going to be produced. And one of the ways to do it is model your process or your equipment using a digital twin model and run simulations and adjust your temperatures. Now, this you can do it safely and without blowing up anything, and cost effectively, because you're not wasting a product, right? Going back to my steel industry experience, the most cost incurred in steel making is the conversion cost, the energy you put in to make the steel, and so you can't do experimentation. But with a digital twin, you can do those kind of trial and error type experimentation, and with the digital twin also, with the machine learning and artificial intelligence, it takes you to the next level. For example, vaccine manufacturing. Or tablet, a medication they're trying to create. Either you mix up a bunch of chemicals and try to see trial and error. You can do that. That's how they used to do. Vaccine manufacturing took anywhere from 12 to 17 years because they were literally performing those tests physically. Of late, they're using digital twins and a lot of automated machine learning and artificial intelligence to build these models to simulate those things really fast and get to 80-90% of the way, and then tweak the remaining 10-20% in the actual plant.
So how does that work, Sri? I don't have a physical plant, or I have a composition for a tablet. So where do I deploy it? Because normally they do tests on they use on what they call as target patients or whatever, and then that's really then they see the impact. That's the way they build over 17-18 years. Now in a digital twin, how do I assess how it works? So is that something which is completely machine learning, and or if it is a product like what you're talking about, 80 degrees or whatever, how it's a completely simulated environment, is it?
Yeah, I mean, the phase 1, 2, 3 trial for a drug product, you still have to go through with the human phase trials before the FDA or any regulatory authority is going to approve your product. You still have to go through that. But to get to the point, they typically did 10, 12 years of creating these concoctions, different products by physically doing it. So originally they automated it using machines, and then they moved to the next step and say, look, the chemicals are going to react this way, that way. This is a subject I'm not really an expert on when it comes to drug products, how they do this. I can go back and give you a simulation of manufacturing in the aerospace part,
Please.
which I'm really very familiar with.
Yeah.
So, when you're building an, say, F-35 fighter plane, one of the things, maybe we shouldn't talk about F-35. There may be some, that may be classified and stuff like that, which I don't know anything about. So I've been out the industry almost 5 years. But let's say if I'm building a product for a new Boeing or an Airbus plane, it's all about lightweighting. So steel is heavy. You can't really put steel in airplanes. So they started using aluminum. Aluminum is lightweight, but it is not as strong as steel. So they started mixing alloys. And so to produce a new product, used to be you mix up, literally, physically, you mix up a bunch of different alloys and to figure out how strong it is, come up with the different strengths, and how it is going to perform in different conditions, temperatures. Is it going to break? If I'm launching this, putting it in a rocket, how is it going to perform in space? Those are the things that they were used to test. So it will take anywhere from 5 to 10 years to do these kinds of testing. So now what they do is, instead of physically testing these things, they have evidence of some of these products, how they behave, characteristics of different alloys and stuff. So they have those things, data available. So they use those data. They do finite element analysis and a bunch of other computational tools. They build those into a digital twin model, and they simulate how a product will perform. And so what it allows them to do is they can eliminate some of the other combinations effectively. So they get you around 50-60% of the way. So that reduces the time frame much less. And then based on those simulations, they go back and they do create those combinations physically, test it, and further refine their models. So the constant model refining goes on. So it never a straight, 80% of the way I'm going to simulate myself. It's a step process. You simulate, eliminate some of the possibilities, and then make a prototype. And so you're reducing, in the meantime, that cycle time that needs to make the product.
So thinking back, is there some learning to take from the digital twins that the manufacturing industry uses for the software and IT industry? Most often, what we really see is, when you deploy tech or a software, the business benefits, or what they call as, the return on investment, or, the TCO as they call it, and therefore the ROI that happens out of IT products is pretty much, I believe, in a manufacturing era where you build products, you deploy them. Do you often measure efficiency? Do you measure productivity? Do you really look at when a release happens, does that release really help the customer? I think there's a lot of learning that the manufacturing industry provides because they've built physical products, they've got data, they then build the digital twins and then simulate them in a structured environment and therefore in a restricted environment, and therefore they're able to see some results and then they're able to build a product. So similarly, the IT industry is, I believe, the software industry is in a manufacturing era where there are lots of hypotheses and biases and solutions that come in a software engineer's mind, but when it gets deployed, is it easy to use? Does it save time? Does it give me better productivity? Are we able to collaborate better? These are themes that are on the basis on which products are built, but do we collect data and therefore can we then start to fine tune it? I think there's a lot of learning that can be picked up from the manufacturing industry and from digital factories, because today's knowledge industry will become digital factories of tomorrow, and therefore there's a lot of learning to pick up and apply them here. You probably were responsible or one of the team members to set up the $3 billion, Sanofi, vaccine greenfield site. Probably the largest. You are amongst the guys there. So how was it to set up as large a greenfield site? Must have been completely automated. What was the kind of scale that they were operating?
Well, so the Sanofi site is actually a 120-year-old site, so it was not a greenfield site, particular site. It's a $3 billion biggest vaccine site. I think it is $3 billion. I may have to go check on it. I put it on my resume, so it got to be. So, but anyway, this site is a close to 1,000-acre site, and it's a huge vaccine manufacturing site. They are one of their biggest vaccine manufacturing sites. Within the site, they were building a $500 million new biologics building to increase their capacity. And it was one of those U.S. government-sponsored projects to build a new capacity in the U.S. Typically, I was not involved in the beginning of that site, so that's kind of a genesis when it comes to the pharma. Whereas I can talk about the $130 million site, steel plant site, that I was involved from day one. I worked in an existing plant almost 10 years, brownfield site in an old steel plant. So I had a pretty good idea of what I wanted to do on a greenfield site. One of the things in any project, when you start doing a project, is what product you're going to manufacture. That's the basis for everything you do right after that. And this particular instance, steel making is there's two kinds of steel making. You have carbon steel making and stainless steel making. They're both completely different products. A melt shop that makes a carbon steel making doesn't make stainless steel making. It cannot make those. But this company decided to do both in the same plant. So that became the basis for how we do. So there's a mechanical design aspect of it. So someone else was doing it. The different equipment they had to buy, different furnaces they had to buy, different power requirements they had to have for each one. So they were doing it. Whereas my job was more related to raw material moving through the plant, how we receive it, how do we do the conversion, what kind of automation we need, what kind of a data we need to collect. So we're doing a data mapping of the entire process. So at the beginning, you do that process, and then you work with the different suppliers. Steel making is almost a 200, 300-year-old industry. They're making steel forever. And so, you also look at the industry, what other companies are doing, and then you come up with a concept design. And then you go about and say, these are the different, I'm going to melt it, I'm going to refine it, I'm going to take the different impurities out, and then I'm going to cast it. And so those are the 3 or 4 different areas. And within each area, we started looking at what we want in terms of equipment. So overall, I also had a philosophy of what kind of a control system I needed. So I had some corporate standards written for each area. Say, I want this particular brand of PLC, this particular brand of human-machine interface. I want this particular SCADA system. And so those are some of my corporate standards. So that becomes a basis for any vendor to bid on the package, to provide a proposal for you. So, a plant like this, it takes almost 2 to 3 years to design, develop, get bid packages, and then use those bid packages to further refine your processes. In the meantime, you're working with your IT groups, your quality groups, to say, hey, I need this kind of infrastructure. IT, can you provide me this kind of a network, wireless network, whatever that is, servers and everything. Quality, what kind of a data that we need to collect, and how are we going to use this data? Work with your metallurgist. What kind of a chemistries we are going to make? How can you predict when steel will be done? Can we build some models for it? So all those things become part of it. So it is a complex process. And obviously, I'm not the only one in this team. And you surround yourself with a lot of smart people who know what they are doing, and then take the benefit of their wisdom. And my role, and then it becomes a more of a you're facilitating the communications and ideas, and then also being pragmatic, what is possible and what is our capex needs and what is available. So you mingle all that, and then have a good project managers to help you, because it is a complex project, right? So yeah, that
And
was my
therefore, what's the kind of outcome did you achieve out of this? Did you achieve the goal that you set out? And so, what was it like, and what were you really, proud about?
It was a $120 million product, and we did build it. And 15 years ago, it was one of the very modern steel making plant in the U.S. at the time. And we did make stainless steel and carbon steel. And the first time we made a stainless steel, it took almost like I would say 48 hours to make one batch of steel, whereas a carbon steel, every hour we will make one batch. So you can see the complexity. There was a lot of learning, and also when we first started, our utilization rate was about 45%. A lot of learning, a lot of changes we had to make. We had some reliability, premature failure issues. So I had to adjust my hat, and we had a lot of teams. One of the teams I was on was how to improve the cast reliability. I learned quite a bit, and we brought the efficiencies and to almost 70% by the time I left the company. So it was when you see the product coming out, that's one of the best satisfactions you can get out of. It's like when I had my kids, that was one of the best joys you can have, and probably it's not as quite as that, but definitely it's a great achievement. You gain a lot of confidence. It's not a hard work. Like it's a 15-hour days non-stop for starting up a plant, 6 to 8 months. You're using all kinds of hours. You're spending a lot of sleepless hours. But at the end, it's all well worth it. And I would say it's one of the very productive, efficient plants. I even took a visit 4 or 5 years later. Twice I actually took two different companies that I worked for on a plant tour of it. I had a good relationship with the company. I haven't done a tour in 5 years of the site, but it's one of those family-owned companies. They welcomed you back. So I was grateful to take a tour back. Some of my people in my team to show them what a digital plant will look like. And,
Okay.
So yeah.
Great.
Yeah.
So when you build the nature of what Sridhar talks about, the digital factory, a completely greenfield project like the steel plant that he talks about, what was interesting for me to observe and look at is the multiple functions that he had to coordinate. and understand. So it's not just about his area and role of saying, let me build a digital factory. I am a manufacturing specialist. Let me now bring my PLCs and SCADA systems and, all other kind of human interface devices into the plant. He had to work with the IT team, help them understand the networking principles that was required. He had to work with the metallurgy team and actually say, you know what, if you're really looking at what kind of a data do you want from these devices to decide on your quality, what kind of data should I be capturing? The ability to think multifunction, to be interdisciplinary, to learn from other industries and apply them is a key skill that I think is very, very important. And as you build new ideas, new factories, new thoughts, the fact that you need to interact and coordinate with multiple functions and help them understand your vision, seek their support, and ensure that their work becomes efficient is something that, as an engineer, as a business head, as an ongoing person who's actually building your career, these become very important. And if you are in a siloed, closed thinking job mode, you will never be able to expand and build large digital transformation projects like a digital factory. So one of the things that I read, which is interesting for me, was you talk about the interdisciplinary learning you had from different industries. Okay.
Yeah.
How important is it for an engineer, Sri, for the interdisciplinary learning?
Yeah, I think it is very important. A lot of times when you go to a new plant, engineers there working in that site 20 years, 30 years, knowing everything about it. I'll give you an example. There was an application in one plant. I won't name the plants. I don't want to embarrass anyone. So the process is, before you can make a product, you have to oil the pot so it doesn't stick to the mold. Seems like a simple thing, but they had people manually doing this work, oiling the pot, and it's a waste of talent. You're putting a guy, it's not a value-added function. You're standing there as a long hose with a metal wand at the end as a nozzle and sprays oil, and he's just, going through. It's like you're making dosa in India. You oil it, and you look like, but every time I see it on YouTube, it's fascinating how it comes off. Same thing if you're making an aerospace parts, you're oiling it. And one of the mandate that we had was to automate this process. And it can be easily done. I can put a robot in and I can teach it, and it will do that all day, every day. So, a robot will cost anywhere from $20,000 to $100,000. An employee, on those days, it was $100,000 per employee. When you're working in a union shop, it's very hard to replace an employee because they're losing an employment, right? Yeah. So that's one of the challenges. My point to them is, look, I could use that person. And the data has shown every time you did an automation, it allowed the companies to expand and hire more people. People think automation, you will lose employment. No, if a company is successful and if they're making profit, they're going to expand. They're going to hire more people. That's what I have seen. There may be instances where automation replaced people, but when you dig deeper, there are other issues why the companies couldn't sustain, and they did what they did. They closed up and things like that. But a well-run company, automation actually enhances and makes them more productive and expand. The private companies I worked, the two companies I worked in my career, they were always like that. They always expanded even with the automation. So his thing was, the feedback from the software was, well, you cannot automate this oiling process because the oiling is an art form, and it's in the movement of the wrist. And that's a mindset, the cultural issue you run into. Not being in other industries, you don't see how even a more complicated process than that is being automated.
Mm,
They have robots, they can put a screw in an iPhone.
mm,
If they can do that, I'm pretty sure you can automate an oiling in a pod. So that's why it's important for engineers. And this comment, it's in the wrist movement, came from an engineer. So that's why it is important, tying all that back to see different industries, have that wide experience and have an open mind. It's like a traveling, right? When you travel, you see different things and your mind expands.
Here, Sridhar talks about the importance of interdisciplinary thinking, learning from other industries. If you're steeped in one industry, it could be IT, it could be software, it could be banking, it could be, mutual funds, it could be insurance, it could be, healthcare. When you're steeped in an industry, you pretty much get into a cognitive bias of saying, you know what, here is the way it gets done here, this is the way to do it. But when you want to transform a digital process, what's important is to look at adjacent industries, different industries, how they've solved the problem, learn from them, and then start to apply it back in these processes. The other important point that he makes is the fact that automation increases more jobs. That's a very, very interesting perspective, because there's a lot of furor, there's a lot of issues around, you're trying to automate this, we're going to keep losing jobs. But the important takeaway that I see from what he's saying is that when you try to automate, you pretty much start looking at the company handling its demand far more efficiently, far more better. The businesses start doing well, and therefore it gives more jobs to people. Therefore, what is important is to look at how automation can transform certain skills, and therefore the need to constantly upgrade yourself to the new skills that may be required when an automation happens is something to think about. So Shri, one of the things that is coming out very, very strongly to me in this conversation is when I look at a heavy engineering, manufacturing kind of a setup where deep engineering is required.
Yeah.
Then the knowledge of the domain that you come with. In fact, as an engineer, you spoke more domain than many engineers would speak. You are not talking about architecture, or you're not talking about some program or whatever, but you're talking about industry issues, and then you went back to solving it. Okay.
Yeah.
While in other industries other than manufacturing, many times I see the knowledge of the industry is pretty much sometimes not there. They probably say that, okay, just program this and give it to me. Okay.
Mm-hmm.
So is that so? Therefore, if I'm an engineer, would you recommend that I do the hard work of working in, say, a manufacturing unit or or an industrial unit, if I were to call it, okay, for a few years, so that it just gives me a hard knowledge of what I can then apply and innovate in other industries?
Absolutely, I think that's a great suggestion. To be honest, you put it in a better light. I would say that is a great thing to do. Having different backgrounds and experiences only enhances your work. Um, y- you know, um, one of the things I learned, or in my tours. Um, uh, Thinking about one time I was in an Alcoa Tech Center, and they were the original suppliers of parts for Apple products. And some of the stories they described how Steve Jobs was so personally involved because they were using aluminum cases, and how he was involved in the aluminum parts making, even though some of these parts were not even exposed. They were not even aesthetics parts. And so, the reason I'm bringing that up is people who are that successful, they are so focused and they are want to know everything. So for me, the best way, everyone cannot be, not going to have that kind of opportunities and mindset like Steve Jobs. So what is the best thing can you do? The best thing you can do is, I'm fortunate, for example, is to be in steel, to be in automotive, to be in aerospace, now in pharma, from life science. Even within pharma, there's life science, there is tablets making, cell and gene therapy is the next big thing. Individualized medication is coming. They take your genes, and these are all fascinating. Every day I learn. And then also I'm able to leverage the things that I learned from one industry, and I'm able to apply in another industry. I feel that helps me to be a quick learner when I change jobs or take up a completely new industry. Allows me to be, I don't want to label myself as successful. That's kind of a self-congratulatory thing, but it allows me to be to start up on any new jobs pretty quickly. I feel that, and I do. So for an engineer, so I'm going to bring this up. You probably might remember it. I was a civil engineer, civil professor in the college. I forgot his name. Shame on me. The one thing he told us was, look, I'm going to teach you, you're going to use some tools that's not even invented yet. Okay, you're going to use those tools. So what I'm going to teach you is how to think like an engineer, so that you'll be ready to use those tools that's not even created yet. Something like that. Okay. To this date, I think about that. I should remember the professor's name, but I don't. It was a basics of civil engineering class. He taught us that, and to me, that mindset comes when you have exposure to different areas. And if you're going to be a programmer in Google, sometimes when I use some of the tools, especially some of the Microsoft products, I say, why don't they get some user input? Oh my God, sometimes I think that, yeah.
Here Sridhar shares a very, very powerful thought of how do you really build a product that's not invented as yet? How do you solve a problem that's not invented as yet? How do you build a product for a problem that's not invented as yet? Therefore, as an engineer, what he suggests, and which I think is something that I totally agree with, is you need to first teach yourself how to solve a problem. And as you build your career as an engineer, as a doctor, as a musician, there are many tools and machines that are going to come your way over the next 30-40 years. And you need to understand that if you were to know how to solve the problem, break down the components into real issues, then any problem can be solved when these new devices come in. Therefore, the fact that you need to really understand core problem solving skills is something that he talks about. And if you are an engineer, the fact that you need to learn these are very, very interesting points that he makes. So therefore, it's not just about doing the job that you do, but it's about learning from different industries, applying one industry learning to another industry, and also looking at things that have never been invented as yet, but you will be thrown these problems in a couple of decades, and you should be able to pick them up and quickly find a solution for them. That's the key skill that you need to build for yourself. Beautiful. So I think that's a very interesting perspective, which is understanding manufacturing. Spending time in the shop floor, coming back and then applying it in services business or programming or
Yeah,
software businesses is a great way of doing it.
yeah.
Which brings me to my last few questions, Sri. These are going to be rapid fire questions. So, uh, what does success mean to you, Sri?
Oh gosh, that's a fully loaded question. Success mean, it's no straight path to success. There are a lot of disappointments and failures, but as long as to me, for me in the family life, that's what I try to tell my kids also. As long as you're trying and be happy in what you're doing, and then you're able to make a living out of what you're doing, to me that's successful. It's not money. Yeah, money is great, and you get to enjoy some of the finer things in life, but as long as you're happy and enjoy things that what you're doing. I look at you, Swami. You mentioned you're able to do what you like. Came from engineering, did something completely different. I couldn't imagine doing that, and then you're doing something different now, completely different, right? To me, that's you're able to do it on your own terms. To me, success.
Brilliant. What would be a piece of advice if you were to give to a 18-year-old in an university today?
For me, attitude is everything. For me, that's so important. That's what I tell my kids, and also anyone I hire, especially fresh grads. Over the years, I had so many interns, bring them in. You don't have to know the tools and technology. You can always learn. But if you have a great attitude and say, "I'm going to give my best," that is important. And also, don't expect rewards on day one. Attitude and put your time in, do your best. The rewards will follow you. Even if it's not on day one, eventually you will get the recognition. And if those recognitions are not coming after some time, after you put in your attitude and your effort, if it is not coming, also don't be afraid to make a change. Those three things to me is important.
You have worked with lots of bosses, lots of people, lots of mentors. What's one piece of advice that you got which probably you use even today or remember even today?
I had a couple of bosses. They said a very similar thing. Is be here, do the right thing. You're a professional. Be here, do the right thing. And as an engineer, you don't time in, time out, but be available. And that's one thing. And the second one is this is something I learned on my own. Be loyal to your team and to your company. As long as you are there, do your best. Okay, you're there, you accepted, you're going to be there. Do your best and be loyal.
What's one thing that you believe in that others don't agree with you?
Oh boy, there's a lot of things people don't agree with me, especially my kids and my wife. I don't know. That's a difficult question, to be honest. Personally, I think there is a uh, especially in the world we live in, there's a lot of skepticism. I tend to think there is always good in people. There are. I try to practice now. Try to give the benefits of doubt, not always successfully, but I hope everybody can believe that, and just to give some benefit of doubt in when you run into some difficult situation or difficult people. Don't get too turned off by some negative uh, you know behaviors or negative feedbacks or negative experience.
Brilliant. If you were to have a dream dinner with a few people who would be on the table and why?
I don't know. Probably my dad.
Hmm.
You know, um, yeah. You know, he a lot of things I do practice and learn. Kind of like getting emotional here, so sorry. Is I learned from him. It's not like he told things or just watching him. And he was a college professor. He was a principal in a small time college in Sattur near Madurai in India. He grew up with his aunt raised him. He pretty much didn't have parents, him and his brother. He grew up very poor. And for 35 years, 40 years, he spent his life teaching kids. And, you used to have 7 days a week, and he will go to the college and he will bike 2 miles back and forth to the college. And even though, he could have got a car, there was allowances and things like that, but he never took anything like that because it will cost money for the college. Um, you know, every Saturday and Sunday he will travel around the different towns and villages collecting donations for the college. And I learned a lot from him. And he never, some people recognize, and I don't know how much recognition he got for his effort, but sometimes I run into people and they will tell, "Hey, I was a dad's student." Some really older people. So for me, I wanted to be like him, and I wanted to tell him that how much influence he had on me.
Fantastic.
So, yeah.
Thanks, Shri. A brilliant conversation. Perspectives which are very, very different. Not normally what I hear. Topic that is not such a glamorous topic because people tend to talk of chat GPT, AI, software, and that's what people want to talk about. But I think we talked about some very hard stuff, a lot of details, great perspectives around how an engineer can learn from doing things and being in the shop floor and then taking that to different industries. Brilliant conversation, and thanks a lot. It was lovely talking to you.
Swami, thank you so much for those kind words, and I hope it is after you look back, some of this stuff is useful, and maybe you can turn that into a useful podcast. And some of the questions you asked were brilliant, made me think. I was pretty nervous at the beginning. I never done a podcast before. Very thought-provoking questions, to be honest. And I think this is an art and asking questions that is, and I really admire. It was brilliant. Thank you so much. Thanks for the opportunity. Definitely.
Thanks for listening to this episode. For selected links and detailed show notes, visit www.contraminds.com/blog. Follow ContraMinds on social media and let us know who you would like to see next on the podcast. If you're listening to ContraMinds on Apple Podcasts, do share your comments and give us a rating. We are keen to know what you're thinking. ContraMinds is also on YouTube. If you're listening to the podcast on YouTube, hit the subscribe button and stay up to date on all our releases. Thanks for listening and stay safe.